Okay, so today I am going to discuss another interesting problem. It is a CSIR NET PYQ actually. As you can see, it is CSIR NET June 2017 PYQ. And it is a important topic of quantum mechanical rotations because it this topic is actually a bit rare. You can find PYQs in NET and JEST and GATE exam also, but this topic is a bit rare because many questions don't come from this topic. This topic is a bit rare. Yeah, okay. So most of you probably have difficulty with this kind of thing, like how to deal with this kind of things. Okay, so they are basically quantum mechanical rotation operators, and how to deal with this, simplify this, we will discuss briefly in this question. Okay, so pause the video first and give this problem a try by yourself and then look at the solution. Okay. So the statement is pretty simple. They are mentioning that sigma x, sigma y, sigma z are Pauli matrices, and they are mentioning you that this LHS is equal to this RHS. So you have to find that how the x prime, y prime, z prime transforms with x, y, z. So what is the rotation operator or transformation operator for this question? And they are giving you this identity. Okay, so let me just quickly do some basic things. Okay, so suppose there is a axis eta. Okay, or any arbitrary direction. Okay, so according to with this axis eta, it is an arbitrary direction. You make a rotation theta. Okay, so if you make a rotation theta, then what will be your rotation matrix? Okay, rotation operator. So the rotation operator is e to the power minus theta in hat, because you are giving this rotation in hat direction. Okay, theta in hat dot your j is the angular momentum. Okay, divided by h cross. Okay, so this is the basic rotation operator. You should remember this formula. Okay, and how it comes? It comes where you have a, I mean, you can say that psi phi is equal to psi phi. Suppose you are expanding it about phi is equal to phi zero, Taylor series expansion. Okay, and then del phi of psi about phi is equal to phi 0. Phi is some angle. Okay, now this, if you can remember that Lz is nothing but minus I h cross del psi. Okay, so it is basically, if you divided it by 1 by I h cross, then it is basically Lz of psi with the division of probably minus h cross. It is just simply Lz of psi. Okay, so that is basically a rotation about z direction. Okay, so if your spin is initially suppose pointing in x direction, suppose this is your x direction, and your spin, you have a spin which is pointing in x direction. Okay, so what is your initial state? Your initial state is this, and suppose now you make a rotation of angle theta along this z axis. So if this is your z axis and you make a rotation of angle theta, so this is your rotation matrix I e to the power theta z hat dot j divided by h cross. This is simply will give you sigma z. I is equal to e to the power minus I theta sigma z by h cross. Sorry, h cross by 2 sz. It will give you sz, and sz is equal to h cross by 2 sigma z. So this is simply your rotation operator, and you have to evaluate the matrix forms of this and apply this matrix to this matrix to get your new spin state. Okay, so this is basically the rough idea. Now in this question you have don't need this much all information. You just simply have to evaluate that what these quantities are. Okay, so they already give you the first quantity. Okay, so e to the power I theta sigma z by 2. Now you have to careful about just few properties, that sigma z square is simply your iota. Iota, sorry, is the identity matrix. Okay, so this is the property you have to follow. And what is your sigma z cube then? Sigma z cube is simply sigma z into sigma z square, that is sigma z into identity. So this pattern will follow. Okay, you have to remember just this thing. Okay, now expand it. Okay, so I plus I theta by 2 sigma z plus I square theta by 2 square sigma z square plus I cube theta by 2 cube sigma z cube and so on so on. Just collect the alternative terms. Okay, so this, suppose you are collecting this term and other alternative terms. Okay, so after collecting the first two terms, you can very quickly recognize that this is nothing but, right, so 1 minus theta by 2 square. If you collect the, sorry, there is a factorial also. Okay, there is a 2 factorial, 3 factorial, sorry, I missed that. So this is this term, and if you collect the next term, it will be 1 by 4 factorial theta by 2 to the power 4, which I don't write here, but if you collect all the terms. Okay, now collect these alternative terms. You can very quickly be, sorry, I sigma z theta by 2 plus 1 by 3 factorial theta by 2 cube, kind of, it will go on. So this is nothing but I into cos theta by 2. Okay, and this is nothing but I sigma z, this whole bracketed term is nothing but sine theta by 2. So this is your operator. This is your simplified version of the this operator. Okay. So you just have to remember this. You can directly remember this but it is a bit hard to remember. So I will argue you to do this kind of expansions in exam hall very quickly. It will just take 1 or 2 minutes. Okay, and just verify the result. Okay, this will very easy to expand it and recollect it. Okay, because there can be plus, there can be minus, and you can confuse in exam hall if you try to remember what is the actual formula. So I will suggest you to expand it in exam hall very quickly and verify it what the actual form. There is no chance to do mistakes if you expand this and recollect this formula. Okay, so now just simply uh, find the matrix form, that is cos theta by 2 into identity, that is 1001 plus I into sine theta by 2, and what is there, this is, that is sigma z, right? So sigma z is what, 100 minus 1, right? So in this case, you will get cos theta by 2 plus I sin theta by 2, that is e to the power I theta by 2, 0, 0, and e to the power minus I theta by 2. So your this entire thing is nothing but a 2 cross 2 matrix, that is this. So now you can immediately guess that what is the form of this term, e to the power minus I theta sigma z by 2. Look, simply I is replaced by minus I, or you can think theta is replaced by minus theta. Okay, so this will be nothing but just switch this minus sign. E to the power minus I theta by 2, 0, 0, e to the power I theta by 2. Okay, now get back to the question. You evaluated this, you evaluated this, and this thing you can evaluate. Okay, I am doing very quickly. So x sigma x plus y sigma y plus z sigma z, right? So you can find it as z z here minus z here, and here you will have x minus I y x plus iy. Okay, you can verify it. I am doing it very quickly. Okay, now substitute all these things, e to the power this thing and this thing. So you have e to the power I theta by 2, sorry, just let me see another. Okay, e to the power I theta by 2, 0, e to the power minus I theta by 2. Here is your z x minus iy x plus iy minus z, and there is another term, but the minus sign swapped. 0 0 e to the power I theta by 2. Now you can calculate this. This will be bread and butter for you. This is the first one. Now multiply these two. So your row 1 column 1, that is j d to the power minus I theta by 2, row 1 column 2, right? So x minus iy into e to the power I theta by 2, row 2 column 1, that is x plus iy into e to the power minus I theta by 2, row 2 column 2, that is minus z e to the power I theta by 2. Okay, just move to next page. uh, that is row 1 column 1, so it will z remains z. Okay, row 1 column 2. Okay, so x minus iy into e to the power I theta, right? X minus iy into e to the power I theta, I guess. Yeah, 0 0 e to the x plus iy e to the power minus I theta, x plus iy e to the power minus I theta, and finally your this thing will remain minus z. Okay, now you have to compare this with the LHS. Now what is your LHS? LHS is x prime sigma s, y prime sigma y, z prime sigma z. Okay. So what is your x prime sigma x, y prime? This is simply z prime, x prime minus iy prime, x prime plus iy prime, and minus z prime. So you can easily, very easily can guess it is a rotation about z direction because the z coordinates doesn't change, and you can easily get the correct rotation operator from this. But if you have to further need further clarification, you can even solve further. That is x prime minus iy prime is your x minus iy into e to the power I theta, is x minus iy into e to the power I theta, that is cos theta plus I sin theta, cos theta plus I sin theta, and x prime plus iy prime, x prime plus iy prime is equal to your x plus iy e to the power minus I theta, x plus iy into e to the power minus I theta, that is cos theta minus I sin theta. Okay. Now you can simply add this 2 to get what is your x prime. So 2x prime, I am adding this 2x prime is equal to cos theta into 2x, that is 2 cos theta x, and uh, x minus iy into cos theta plus I sin theta minus cos theta 2y sin theta, I guess, right? So minus iy common, I sin theta minus yeah, 2y sin theta, I square minus 1. So x prime is equal to x cos theta plus y sin theta, and you can easily get what is y prime. Okay, so you can get the correct matrix operator, that is this one. Okay, so x prime is cos theta plus sin theta y. So this is cos theta sin theta, we already find, right, that x prime is equal to x cos theta plus y sin theta. Now look at the options. This is theta by 2, just directly eliminate this 2. Now you have to find between these two, and already find that this 2 should be plus. Okay, so what is your rotation? How is your rotation? You have z axis and you gave a clockwise rotation, you would rotate it by theta. Okay, so this is your new x prime, this is your old x, this is your old y. So your new x prime is x cos theta plus y sin theta. Yeah. Okay, so this is your rotation matrix theta, you are giving rotation clockwise. So yeah, this will be the correct option. And you should this form is given in this question, but if in question it is given that you are giving a rotation about rotation, you have a in cap direction, and the direction is given to you, and you are making a rotation theta clockwise. Okay, so your rotation matrix will be, your rotation operator will be I theta in hat dot j by h cross. Okay, j I am telling at a very specific reason, because if only spin is given, that j is simply by the spin matrix. But if some additional orbital angular momentum will be given, then j is l plus s. Okay, so this is the generalized j. Okay, so this will be the form of your rotation matrix. You should remember this. And obviously, you can read this topic a little bit, because this topic a bit rare. It is there in ZT. Okay, rotations and angular momentums kind of chapter there is, and you can read this topic. This is an important topic actually. This is a rare topic. Questions rarely come, but question comes. Question comes in NET. Question comes in JEST. You can see PYQs. Okay, so yeah, this is a rare and important topic. You should read this topic from book. So yeah, okay, that's it for today.